If you've just watched the first part, this would be a good time to save and move the pattern 1 chop down below, or if you're starting afresh, just create a pattern 1 chop. Operators do all the work of processing and outputting data in TouchDesigner. The output of each operator is affected by its inputs, its parameters, and in some cases the current time. So let's look at the characteristics of parameters. The most common types of parameters are integers, floating point numbers, on-off toggles, menus, text strings, and more. Now each parameter can have 1, 2, 3, or 4 values. Create a circle top. For example, when a parameter is a color, it has 3 or 4 values for red, green, blue, and sometimes alpha. So each parameter can be in one of 3 parameter modes, which means each parameter can be controlled in 3 ways. First is the simplest. On the parameter dialog, you just click on a slider, or type in a number, or pick something by hand from a menu. It sets its constant value. Now the other 2 parameter modes are super powerful. They're called expression mode, when you can put Python expressions, and thirdly export mode, where the parameter is driven by numbers coming from chops. You can switch between all 3 modes. So first, let's look at exporting. For that, we need to know more about chops, channels, and samples. Quite simply, chops output numbers. A channel operator creates a set of 1 or more channels, and each channel is a set of numbers, or samples. So let's create a constant chop. And move its slider. It has 1 channel and 1 sample, as you can see if you middle click on the node and see 1 eye, which means 1 sample or index, and 1 channel. The channel name is down here. Now click under Chan 1 and type Chan 2. So it is now outputting 2 channels, each with 1 sample. Now create a noise chop. This is 1 channel with multiple samples. To prove this, zoom into the node a bit, turn on Viewer Active, right-click on the graph, and select Dot per sample. Now we want to zoom in further, middle-click and drag the mouse to the right to reveal a dot for every sample. And be aware that the mouse clicks on the node do different things depending on whether the viewer is active or not. So press H over the noise chops graph to home the channel. And on the parameter dialog, click the channel page and change the channel parameter to Chan square bracket 1-3. There are now 3 channels, each with 600 samples. To verify this, middle click on the bottom of the node where the name noise 1 or 2 is located, and look at the pop-up info and see that it is 600 samples long with 3 channels. Now to see chops as numbers, bring up opcreate, select that for data operators, and create a chop2dat. Then turn on the parameter called include names, and then turn off the viewer for the noise chop. Drag and drop it over to the chop2dat, and you can see the 3 channels are represented as columns, with channel headings being their names, and the value of each sample in each row. Now drag and drop the constant chop onto the same node, and you can see that there are 2 channels, but with 1 sample each. So overall, chop is used to represent a curve, a motion, an audio signal, or a control signal in TouchDesigner. So exporting sends a value from a chop channel to an operator's parameter. Create an LFO chop. Slow its frequency down. And connect it to a new math chop. Make the math chop's viewer active and create a movie file in top. Right-click on its output and create a transform top. Now left-click the channel in the math chop's viewer and drag it to a parameter in the parameter dialog. Say the transform top's translate X parameter on the number. Let go and select Export Chop from the menu that appears to complete the export. Note the parameter goes green, indicating the parameter is in export mode. Now select the math chop again by box picking it or clicking the name bar at the bottom, and now you can adjust the motion range by selecting the multi-add page of the math chop and adjusting the multiply parameter. Now you can turn off the export by turning the viewer active off and clicking the export flag off. So if we go back to transform, we see it's restored to its original constant state. Go back to the math chop and turn export on, and it's exporting again. Now let's look at Python expressions in parameters. Expressions are used in parameters and scripts. The preferred language in TouchDesigner is Python, although you will see TScript in older work. Create a new pattern chop. And call it Sign1. In the length parameter, type the expression 200 star 3 times 3. The value now shows as 600, as the expression has been evaluated to 600, and is now blue to indicate that it is currently in expression mode. To reveal more, put your cursor over the parameter name length, and a plus appears, and click anywhere in that area. A new row appears showing the Python name of the parameter on the left, length, a box for the 3 parameter modes, and the optional Python expression. Click the gray box to the left of the blue box. This puts it back into constant mode, where the value is still at its default value of 1000. Now this is useful for trying out different values before committing to it. Click the expression mode box again. The third parameter mode is export mode, so if you go back to the transform top that holds the export and click on translate, you will see TX is in export mode, represented by green, and you can see where the channel comes from. It comes from the chop math1 and the channel called chan1. Now on Sign1, click on it. In the parameter called number of cycles, the expression me.digits plus 2. It evaluates to 3, which is the digits in the operator's name, plus 2. Now select just the me.digits parts of the string and put your mouse cursor over it. it shows that that part of the expression evaluates to just one, me.digits, which is the value of the number at the end of the name of sign 1. Now, to enlarge the parameter dialog to get more space, put your cursor over the left edge of the parameter dialog and get the left-right arrow cursor. Click and drag it to the left. To bring up a text editor, if you click on the expression, press Alt-E, it brings up a text editor on that expression. Now you can look at the most common Python expressions. If we go to Wiki, click Python tips, and scroll down, and the most common expressions that you would put in parameters are here. Now, components is the operator family that holds inside them networks of operators and gives rise to the hierarchy of networks in TouchDesigner. So let's create a component with an input and output operator. Press Tab, select Comp, and select Container, and place it in your network. Go into the container by roller wheeling forward or pressing Enter, and verify your path location in the top of the pane. Now create a ramp top and right-click on the ramp top's output and select an out top. Now create a chop, an in chop. Go back outside the component, press U or roller wheel backward, and create a beat chop by right-clicking on the component's input. This connects the new beat chop to the input of the component. Go back into the component, select the ramp top, and export from the in chop to the ramp top's phase parameter, and you can see the ramp rising. Go back outside the component, and on the container's panel page, click on container, change the background top to /out1, which we'll explain later. Right-click on the output of container, put a null. You've now created a custom component with a chop input and a top output. From here, you can take the math chop and wire it to the input instead. A path is like an address of a node or operator. It describes where a node is located in your TouchDesigner project. Create a select chop, and type in the operator parameter /project1 /pattern1. Many operators have a path parameter that refers to another operator. Nodes are all in a tree-like hierarchy of components inside components, starting at root, which is named /. Click the home icon to go to root, and now click on the / to select project 1, and we return to where we were, and this shows us where our location is right now. So let's look at the select chop again. / at the start of a path means it's an absolute path, where in root / there's a component project 1, and in project 1 there is a node called pattern 1. Here are other forms of a path. Create a select top, and put in its top parameter, transform 1. Transform 1 is a relative path. When you see an operator name without a prefix, this will be in the current network. Create an info chop. And put in its operator parameter, container1 /out1. This is also a relative path. Container1 is a component in the current network, and out1 is a node inside container1. Now your container1 component already has ./out1 for the background image. So / means inside this component, so the path means inside this component is a node called out1. Now go into container1 and create a select dat and put in its first parameter ./shop21. So / means the parent network, so the path means in the parent network of the current component there is a node called shop21. Now in Python expressions you'll often see another form of a parent. Create an evaluate dat and in the expression put parent .par.w, and this means the parent node's parameter called w, which is this one. Now let's render something in 3D with the render top. Create a container component, go into it, create a render top, and then create 3 components: a geometry component, a light component, and a camera component. The dashed lines indicate that the 3 nodes are already referred to by render. If you click on render, we see that the camera is already set to cam1. Geometry star means all geometry components, which is just this one. And lights star means all lights, which is this component. Now go to the parameters of Geo1 and change the rotate Z value to 20. And you see the render changes. Now go into the geometry components viewer and tumble it. And notice that nothing changes with the render because this only changes the view of the object. So this is your basic render setup. Now put in the first parameter, now put in the first value, the rotate X of the geometry, abs time dot frame, and this will produce a continuous rotation. So abs time dot frame means the absolute time means the absolute frame number, which is a number that continues to rise until you quit TouchDesigner. Let's go back up one. Now the timeline is located at the bottom of the main TouchDesigner window. The FPS at the bottom left is the number of frames that TouchDesigner will step forward every second. Now note that the FPS at the top of the window is the actual number of frames that TouchDesigner drew in the last second. Now the timeline down here lets you pause, step forward, and play forward again. Also, if you hold down Shift and press the space bar, it will pause and continue forward as well. Now you'll see when the timeline reaches the far right, it loops to the beginning of the timeline. But TouchDesigner is mostly event-driven with a free-running clock, so most things you build don't follow the looping timeline and its frame number. For example, create a constant shop, set its value to 1, and pass that to a speed shop. Now speed is counting up by 1 unit per second, and it's unrelated to the timeline. The thing that resets speed is if you go to its reset parameter and hit pulse, it'll start counting from 0 again at that point. Now create a movie file in top, and on the file parameter, select plus. And now select the movie called count.mov, which is a movie whose text starts at 1 and goes to 100. Now if we change the play mode to locked to timeline, you'll see that the movie file resets to 1 at the beginning of every cycle and just loops until it reaches the end of a cycle again. Now if we turn on sequential, the movie will play sequentially but not be tied to the timeline. And it can be reset with the pulse cue. Now let's set this to play mode, specify index, and change the units type from F for frames to fraction, fraction being 0 to 1. Now let's make the viewer active and export from the speed shop to the index and select export. And now the movie file in will play a whole cycle every second because this goes up by 1 every second. So again, this is untied to the timeline. And once again, if you hit reset, pulse, it'll restart the movie. So let's create animation curves with the animation editor. Create an animation component. By default, it outputs a chop with no channels. Now right-click on the node and select Edit Animation. Or you can press Edit Animation in the parameter dialog. Click on Add Channels on the left, and 3 channels will be created called TX, TY, and TZ. Keyframes are the dots on the channels. Click on any keyframe and move it anywhere. To add additional keyframes to any channel, use Alt and left mouse button and click on the location you want to keyframe. Use the right mouse button to box select. Move the value. Box select the curve itself and go to the function menu and change cubic to linear. Now watch the timeline at the bottom and the values of the channel in the animation component viewer, and note that the channel values follow the timeline. If you want more control of the timing, connect an animated channel to the animation component's input. Create a beat shop, connect it to the input, and go to the animation component and set the input index unit parameter to fraction, which means we'll go through the entire cycle for every ramp. Now create a constant shop and connect that to the input and modify its slider. We're adjusting the index by hand. In both cases, the 0 to 1 value will control which part of the animation curve is output, which decouples the animation component from the timeline. You can always change play mode to output the full range, which is the entire curve. Right-click on the output, set it to null, and this outputs full-length channels. And here's another way to create an animation curve more automatically. Create an LFO. Go to a parameter, like amplitude, and say keyframe parameter in a new animation, and it will create an animation component already wired and exported to that parameter. Let's close the pane. Now, data operators we've touched on already, but they're very powerful text manipulation operators. Put down a web dat, and if you're on the internet, if you hit fetch, it'll fetch HTML. So this is to illustrate that DATs hold text. It could be shaders, scripts, any form of text data. Another form of DATs is tables. So create a monitors DAT, and this will automatically create a table of rows and columns of cells. Each contains a text string. This happens to have another node attached to it, which is a template for Python code. There are a lot of operator types in TouchDesigner, but the most common and useful operators in each family are the Sweet 16s. Go to the wiki, go to operators, and click on chops, for instance, and you'll see down here what is considered to be the most commonly used chops. 16 and the second set of 16. So these are the most important ones to learn. You can also look at the Sweet 16 tops, sops, and dats as well. Now, one way to learn more about operators is to see them in small examples. Under Help, under Operator Snippets, it opens up a separate new process containing examples of the operators. So here you have the families, and you can select families and sets of examples, which you can cut and paste into your projects. You can also open up the palette and drag drop components from the palette into your network. And finally, you can get components from the forum. One of the centralized places is the shared TOX components forum. Now let's look at the performance monitor. Go to Dialog, select Performance Monitor, and click on Analyze, and you'll see a snapshot of what happened over the course of one frame. This is the cook order of what cooked during that frame and how long each cook took in milliseconds. You can see which nodes take the most time to cook, and you can possibly do things to minimize their cook time. It also shows when the GPU is busy computing an image and the total frame time. Another way to analyze is to pull out the probe, and that will give you a graphical representation of what's cooking, where, and in which networks. Finally, let's look at a bunch of quick tips and good habits. Click on the bullseye here to see which parameters in an operator are at their non-default values. You can color code nodes by pressing C, picking a node, and selecting a color. or none. Press C again. Now press O to bring up the overview of a network, and you can click the box and move around larger networks. Press O again and H. Control F will bring up a find node, type sign, and it'll highlight the node that it finds. To look at the nodes another way, you can press T to go into table mode, which lists all the nodes in a list, and you can select nodes here and look at their flags and change their flags. Now when you don't have a mouse, you can zoom and scroll the network by pressing Control plus, minus, up, down, left, right with the arrow keys. In the Op Create menu, you can create nodes in a row. Bring up Op Create, hold down Shift, and click Constant, Math, and Null, and you can see that they're created and pre-wired in a row. Node names are all case sensitive, so for this name it would have to be referred to with lowercase math. And finally, when wiring, you can place your wire close to the existing wire to connect. And that's it.